This is Chapter 3, Numerical Techniques for Describing Data, and in this lecture we're going to cover sections 3.1, Measures of Central Tendency, and 3.2, Measures of Variability. Measures of central tendency. You've probably heard these terms before when we start discussing the measures of central tendency. What we're going to see in this section are ways we can determine the most typical data values within a distribution. Typical data values give us an idea of the center of the distribution when it's organized in ascending order from smallest to greatest. For example, if all the test scores for students who take an exam are considered, measures of central tendency will examine the average or typical score of the distribution. The three measures of central tendency are mean, median, and mode. And you may have seen these before. The first one is the mean, also known as the average when it's used in common everyday terms. And we calculate the mean by taking the sum of all the data values in a data set and then dividing by the total number of data values in that data set. The mean of a sample is determined by summing up all the data values of the sample and dividing this sum by the total number of data values. The symbol for the sample mean is x with a bar over it. We say x bar, and that is right here, x bar. The formula to calculate the sample mean is, and here's our formula, x bar equals sigma x, that's an uppercase Greek sigma, x means take all of the data values in the distribution or all of the data values in the data set, add them all up, and over n means to divide by the size of the sample. So this is a very common calculation. You've probably done it many times before, but this is how we denote it in statistics. Sigma x over n. It means take the sum of all data values x and divide by the size of your sample. It's often impractical or impossible to obtain all of the data values of a population. In such instances, a sample is selected from the population and the mean of the sample is calculated and can be used as an estimate of the mean of the population. So we will use x bar to estimate the population mean. The population mean is denoted by the symbol mu. This is a Greek letter, lowercase Greek mu. The formula to calculate the mean of a population of size capital N is mu equals sigma x, again take the sum of all x data values in the distribution, which would be the entire population, and then divided by n means divide by the size of the population. So in both cases, in both the mean of the sample and the mean of the population, the calculation is identical. Add up all the values and divide by however many values you have. It's just the notation is different. You have to recognize that mu is used for a population while x bar is used for a sample. Example 3.2. A quality control inspector of a battery manufacturer would like to estimate the life expectancy of the manufacturer's 9-volt batteries manufactured during the day shift. In order to estimate the life expectancy of all the batteries during the day shift, a sample of 20 batteries was randomly obtained. The following data represents the battery life in the months of the 20 batteries. Okay, in red here, you are given information that's important. That's why it's highlighted in red. It's indicating that you are working with a sample of 20 batteries. So the values that you're about to see, these values don't represent population data, they represent sample data. And so when we calculate the sample mean, we have to denote it using the proper symbol. And the proper symbol for a sample mean is X bar. So to calculate the sample mean, it's simply adding up all these data values and dividing by the total. So we can do that on our calculator. Okay, let me have this on one side, the calculator on the other. Okay, here we go. So a good technique for doing calculations involving the mean is to use parentheses, so you could wrap the entire numerator in parentheses. So I use the open parentheses right here, and then I'm going to put in the data values: 20 plus 11 plus 15 plus 18 plus 24 plus 17 plus 19 plus 12 plus 19 plus 22 plus 18 plus 15 plus 19 plus 21 plus 20 plus 15 plus 17 plus 24 plus 16 plus 18. That's the numerator, where you add up all the data values and then divide by, there's the denominator, 20 months. Enter. And the answer here is 18. So going back to this PowerPoint presentation. Okay, so X bar, which is the mean of the sample, is the sum of all data values, X, divided by the total number of data values in the sample, N. If you add them all up, you'll see it was 360 divided by 20. It's okay, we just did it in a complete step on our calculator. It's okay to do this in one step, and we got the same answer, 18 months. So X bar is 18 months. Another example, according to the U.S. Department of Energy, the following data represent the estimated miles per gallon for the 2006 mini compact cars under city driving conditions. And we have the following. Okay. Assuming these estimated MPG represent the population of all mini compact cars, find the mean of this population using the appropriate symbol. Well, because these numbers represent a population of values, not a sample, the correct symbol would be a mu. So we're going to add them all up again. On your calculator, you could do the same procedure. Add them all up and divide by the total. So you can pause the video here because I'm going to go ahead and show you the answer. But if you want to try it out, pause the video and redo the same calculation as before, except change your data values to these right here. And how many do we have in our sample, in our population? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so we take the sum of all the data values, divide by the total number of data values in the sample. That's 377 over 19. And mu, which is our symbol for the population mean, is approximately, that's what the approximation symbol looks like, 19.84. Okay, of course, on an exam or web work, homework, or anything that's requiring a grade, you would have to be asked to give specific number of places to round to. This answer is rounded to 2 decimal places. So these are this is information you would need to know before you submit your answer. But because it's not an exact value, it's an approximation because we are rounding, that's why we are using the approximation symbol, not an equal sign. Example 3.7. Given the following ages of 7 children at a playground, and we have 5, 4, 4, 8, 4, 9, and 8, 7 data values, compute the mean age x bar. So just because we know that x bar represents the mean of a sample, these 7 children must be from a sample. And then we're going to do another step. This is interesting. We're going to take the sum of all the data values minus x bar, which is called the sum of the deviations from the mean. Before we can do that, we must do step A. So to find the mean age, you're going to add up all the data values and divide by 7. So adding up all the data values, you have 42. The size of the sample is 7. 42 divided by 7 is 6, and that is the value for x bar. Now, to calculate the sum of the deviations from the mean, we have to first recognize what a deviation from the mean is. X minus x bar is a deviation from a mean. Each of the values in the sample is considered a value of x. So 5 is the first value of x, 4 is the next, then 4 again, 8, 4, 9, and 8. Each of these are values of x. X minus x bar means to take the value of x and subtract x bar. 5 minus 6. 4 minus 6. Okay? You're taking x minus x bar for all 7 values. Okay, so if these are the values in our sample and we take x minus x bar, in the next column I'm going to put the answer for what happens when you take x minus x bar. So for example, 5 minus 6 is negative 1. I'm going to put that right here. 4 minus 6 is negative 2. I'll put that right here. And then we're going to go down the whole list and put the values when you take x minus x bar. Okay, so our answers are negative 1, negative 2, negative 2, 2, negative 2, 3, and 2. Now when we put a sigma in front of that symbol, sigma means add all of those up. Add all of these values up. And if you add them all up, and you can do this on your calculator, you can do it in your head. Negative 1 minus 2 is negative 3, minus 2 is negative 5, plus 2 is negative 3, minus 2 is negative 5, plus 3 is negative 2, plus 2 is 0. So the sum of all x minus x bar equals 0. I'm going to show you that on the calculator real quick. Okay, so negative 1 plus a negative 2 plus negative 2 plus 2 plus a negative 2 plus 3 plus 2. Enter. 0. So remember to use the negative key instead of the minus. They're two different things. So here's your negative key. Now, the fact that it's coming out as 0 isn't a coincidence. It's not like it's going to be, it's not like this particular set of values is coincidentally giving us a sum of deviations of 0. It turns out that if we do this for any set of numbers, if we take all the numbers in the data set, find the mean, subtract the mean from every number in the data set, and then add up this column, no matter what our starting numbers are, we will always come out with 0. no matter what.